Applications, you all are going to learn how to use quadratic properties to solve real-world situations. So things like finding the vertex, the x-intercept, other random things are going to all play into these real-world applications. So you already have the notes that you need to do this. Now let's just look at some examples of applications that you could have. So the first one, it says a rocket follows a parabolic trajectory. After t seconds, the vertical height of the rocket above the ground in meters is given by the equation h of t equals 37t minus t squared. Okay, so what does t represent again? The time in seconds, and h of t represents the height. In other words, t is x and h of t is y. Okay, now real quick before we go into it, does this quadratic open up or down? How do you know it opens down? You have a negative t squared. Look at that squared term. Since it's negative, that's your a value. -1. That means it opens down. Okay? And if you think about it, a rocket starts off at the ground, does it not?
Yes.
And then it shoots up, and then it comes back down, right?
Yes.
So it shoots up, gets to a what? What is this called? It's the vertex, but it reaches a maximum height, and then it's going to come back down and hit the ground. So when it says find the height of the rocket above the ground after 10 seconds, it's basically saying, okay, on my time axis, at 10 seconds, what is the height of that rocket? How do I find that?
Plug it into the equation.
Plug what?
10 to t.
Plug 10 into t. So I am looking for basically h of 10, the height when t is 10. So that's 37 times 10 minus 10 squared. Let me type that. Excuse me. Let me type that in and we figure out what that is. What you get?
270.
270. So the rocket is 270 meters above the ground. Now it's asking you to find the maximum height of the rocket. The maximum height is located in what part of this parabola? At the vertex. More specifically, what part of the vertex do I need?
Y value.
You need the y value because y represents the height. The x value would tell us how long it took for the rocket to reach its maximum height, but it's the y coordinate that tells us what the maximum height is. Okay? So we need to find the y coordinate of the vertex. Unfortunately, the only way we can find the y coordinate is by finding the x. Okay? How do I find the x coordinate of the vertex? X equals negative b over 2a. What's b in this problem? 37. And what is a in this problem? -1. So the x coordinate of the vertex is whatever 37 divided by 2 is. 18.5. And then I need to find the height. How do I find the height? Where do I plug it in? For t in the original equation. So I'm basically finding h of 18.5. So 37 times 18.5 minus 18.5 squared. $342.25.
Yes.
Okay, we can actually write out that whole thing, 342.25. Why can I write out the whole thing?
Exact.
Because it's exact. Okay, remember, it will say leave your answers exact or correct to 3 significant figures. If I wanted to round it to 3 significant figures, what would my answer be?
342.
342, and that too would be acceptable. Questions so far? All right. It really truly is like, okay, so in this particular problem, what is it asking me to find? It's asking me to find a particular height, the vertex, maybe even when it asks me to find the length of time the rocket is in the air, what part of our quadratic properties do you think I'm going to need for that? X what? You need your x-intercepts. Yes.
Since when your x-intercept would technically at 0, and then the midpoint is at 18.5, will you just multiply the midpoint by 2, and then you would just take the x-coordinate?
Yeah. You can do that for this problem. The reason why that you could basically take your 18.5 and multiply by 2 to get your other x-intercepts is because one of your x-intercepts is at 0. Okay? And you know this because one thing you could do is you could set this equal to 0, and you could factor this. First thing you look for when you factor should always be your GCF. Is there a GCF here? Something that both terms have in common? They have a t in common. So I can factor out the t. When I factor out t, what am I left with?
37 minus t.
And so you know that t equals 0. That meant that it had to cross at the origin 0, 0. What's the other t value? It's the same thing you would get if you doubled 18.5.
Oh, shoot.
37. Because you would have 37 minus t equals 0. Add t to both sides. T equals 37. Okay. So how long is the rocket in the air?
37 seconds.
For 37 seconds. Now, if this was any other number besides 0, you would need to subtract the two values from each other to get exactly how long the rocket's in the air. Evaluating a function, finding the vertex, the x-intercepts. Questions? So make sure that you find your x-intercepts. One of them won't always be at 0, 0. But wherever those x-intercepts are, once you find them, you want to make sure you subtract them to find the length of time, whatever the object is that was in the air. Okay? Let's look at the next one. A company's weekend profit. Is that yours? Yeah, that's the next one. A company's weekly profit in royals is modeled by a function, okay? It's very nice when they give us a function because that means we don't have to create a quadratic. However, the last two we will have to create it. Where U is the number of units sold each week, and of course P of U represents the profit. Does this parabola, because it is a quadratic, open up or down?
Down.
It opens down. And more specifically, where is the y-intercept?
Negative 3,000.
Negative 3,000. So basically, that's this right here. Okay, this is an example of one that does not cross at 0, 0. Okay, because the y-intercept is at negative 3,000. It does open down because A is negative. And when it asks us to find the weekly profit, maximum weekly profit, what am I looking for? What part of my parabola am I looking for?
The vertex.
What part of the vertex?
Y.
Because it's asking for weekly profit, and profit is your y-axis. Okay? Now, we just did this, so I'm going to trust you guys to find, actually, we'll do it this way. Let me show you another way that we could do it. We know how to do it algebraically because we did it in part 1, or the first question, but let me show you how to do it in your calculator as well. Either one would be acceptable. So, go to the graphing feature in your calculator and type in that function. So we have our function in. Now, just based off of this sketch that I've drawn here, I know that I can't have a standard window. Okay? So let's go to my window and let's see how I can adjust some things. First off, what should my x minimum be? What would be a good x minimum?
3,000.
Minimum. What does x represent?
Oh, time.
No, not time. Units. So some type of product that they are creating. So you can't have a negative unit. So a good x-min would be 0. However, we could produce a good number of units. So somebody give me a good number.
5,000.
5,000. It might be a little too large, but we can adjust. Okay, I'm going to leave my X scale to 1. Now my Y minimum. My Y's represent my profit, and I already know that I have a Y-intercept of negative 3,000. So you want to use that?
Yeah.
Okay. So at least then we'll see the Y-intercept. What about a max? What do you want to do?
4,200.
That's an interesting number. 4,200? Okay. I'm not going to agree nor disagree with it. Let's just see what kind of graph we have. Okay? So we opened up our X's, our units, very wide because we see both X-intercepts, but I can't see my maximum profit. So then that means that I'm going to need to adjust what part of my window? Your Y max. So it has to be bigger than 4,200. Suggestions?
6,000.
6,900.
Let's go 6,000. Okay? I gotta go bigger.
10,000.
I want to do 100,000. Okay, that was too much. All right, that one was too much, but I still see my maximum, so that's all that matters. Okay, that's all that matters. So to find my maximum, to find that Y coordinate, I need to go to second trace. Does everybody have this graph?
Mm-hmm.
Second trace. And what feature should I go to? 4, because I'm looking for a maximum. This is a maximum. Now it says left bound. That means you need to move your cursor to the left of the maximum. Right now my cursor is at 2,500 negative 88,000. It's on this part of my graph. So I need to move over to the left. Come on. There we go. Of my max. How far left? To be honest, it really doesn't matter. It could be a little bit to the left. If there are multiple maximums or minimums, you don't want to go too far because then it might register the minimum. But I go to the left of my max and I click enter. Now it says right bound. So that means I need to go to the right of my maximum. Doesn't matter how far right, just somewhere to the right, and click enter. And if you have one of these fancy calculators, you'll see these vertical lines. My maximum should lie somewhere in between those lines. If you don't have it, you'll still have those 2 arrows. Your arrow should be enclosing the maximum.
So wait.
Uh-huh.
If that second line, you press enter again.
Yes, you press enter again.
Okay.
And then it should say guess. Does everybody's calculator say guess?
Mm-hmm.
It should, unless you click enter one extra time, and then it gives you your maximum. It actually gives you the vertex. That is what we would get if we did it algebraically.
I didn't do that. I went to left. This.
So what's my answer? What's my maximum profit?
719.
That's my units. That's how many units I will have to produce to create my maximum profit. My maximum profit is the Y coordinate.
1,531.25 real.
Mm-hmm. And again, that's the same thing we would get if we did it algebraically using negative b over 2a and then plugging that value in for u. The loss for the week's holiday period where no units were sold. If no units are sold, that means that u equals 0. And so that basically means we would plug in 0. But we can easily look at the graph and see that that's basically this point right here. How much did they lose? 3,000. Now it says for C, find the number of units sold each week at the break-even point for the company. What does break-even mean?
Like when they're not making a profit, but like they are making enough where they're not losing.
Y equals 0.
So that's where Y equals 0. Yep. So find the number of units sold each week at a break-even point for the company. Now, if you look at this graph, yes, you see 2 x-intercepts. But which one do I want? You want the one... You want the one on the left. That's your break-even point because at that particular point, you have basically Down to the point where you've made up for all your losses to produce all the products, and now it's all about making money. Okay? This other one is basically the other point where you go back to losing money. Okay? So I want that particular x-intercept. Now I can easily set this equal to 0, and I can't factor it. So I'm going to go back to my calculator, and I'm going to find that x-intercept. Now I'm going to cheat. I'm going to be a little lazy. I'm going to go to y equals, and I'm going to plug 0 into y2. I'm going to go back to my graph, and now I have a red line that pops up. Now I can use what feature of my calculator? Intersection. How do I find intersection? Second trace, option 5. Careful. I want to make sure I'm close to that x-intercept. Right now, I'm actually closer to the one on the right, so I need to move my cursor to the one on the left. So I move it closer to the x-intercept I want, which is the one on the left, and then I'm going to click enter how many times? 1, 2, 3. Did you guys get this?
68.4.
But I got a question. Can I have 68.47 units?
No.
No.
So how many units will need to be sold in order for them to break even actually?
69.
69. How are these application problems coming? Let's look at example 3. It says a farmer wishes to fence in the maximum possible area to make a rectangular field. She has 150 meters of fencing. One side of the land borders a canal. We're going to find the maximum area of the field. Okay? Whenever you have to create the equation yourself, like we have to here, you need to know your old school properties. Okay? What shape is this? What is the area of a rectangle?
Base times height.
Base times height or length times width, okay? So, based off of this picture, we have a width and a length. The red basically represents the area that we're going to be fencing off, and we are looking for maximum area. So, area equals length times width. Now, unfortunately, we have 3 variables here. We have not worked with any problems that deal with 3 variables. We need 2 variables, okay? That's where this 100 meters of fencing is going to come into play. What is a fence?
A perimeter.
I like that math word. It's the perimeter. It's what you put on the edge around your property, correct? So not only are we going to need the area formula for a rectangle, we're also going to need the perimeter. What is the formula for perimeter of a rectangle? P, 2W plus 2L. That's a normal rectangle. But one of my sides has a canal. Am I going to put a fence around the canal? No, you're not. So it's actually going to be altered. It's actually going to be 2W plus L. So we need this equation as well. So we're not going to put nothing on that second length right here because that's where the canal is. All right? And we know that we have 100 meters of fencing to use to line this this area. So that means that perimeter is going to equal 150. And in order for me to get the equation for my area of a rectangle, that's the one I'm working with, I need to use this equation for perimeter, solve for one variable, and plug in. Which variable do you want to solve for?
L.
So to solve for L, I'm going to subtract 2W from both sides to get L equals 150 minus 2W. I can now replace my length with this equation in my area formula. So, area equals 150 minus 2W times W. What should I do with that W?
Distribute.
So I now have 150W minus 2W squared, and there is my quadratic equation to represent the area of this field. All right, so now that we have our quadratic, it's asking us to find the maximum area of the field. The maximum of this parabola that opens, which way?
Down.
It opens down. We're looking for that top point. We're looking for the what coordinate?
Next. Vertex.
We're looking for the vertex. What part of the vertex? The y. Because in this case, W is our x and area is our y. So we are looking for the y coordinate of the vertex. Can you guys do that algebraically? Find the y coordinate of the vertex?
How did you turn it into a graph?
Well, we know that since A is negative, it has to open down. And so I just drew a parabola to open down. I also knew that one of its x-intercepts was at 0 because there was no constant term. Now that's just me working with math and trying to provide a visual for you all. But you could type this into your calculator and get the graph as well. So find my y coordinate algebraically, please. Find my x coordinate and find my y. So to, again, find your y coordinates, you need to find your x coordinate by doing negative b over 2a. You find that value, and then you plug it in for w into the original equation. What'd you guys get for your final answer?
2,812.
812?
0.5.
So like that? And this is in feet, meters. So that is our maximum area.
So after you do negative.
For the last example, if a farmer has 170 meters of fencing to fence off a rectangular area, we're asked to find the length and the width that give the maximum area. So very similar to the other problem, we are looking for maximum area, the length and the width. So that means we're going to be dealing with the equation L equals W times A equals W times L. But this time we do not have a canal that's cutting off one of our sides. So when we do our perimeter equation, we are going to use 2W plus 2L. Our perimeter for our fencing is 170, so we'll have 170 equals 2W plus 2L. And just like before, we are going to need to solve for one of our variables to plug in to our area equation to help us find our length and the width. So we're going to solve for any variable, it really doesn't matter. But let's go ahead and let's solve for L. So I'm going to subtract 2W from both sides, and then I'm going to divide everything by 2 to get L by itself. Now when I do that, 170 divided by 2 is 85. 2W divided by 2 is just the W. So 85 minus W equals L. So now I'm going to plug 85 minus W in for L in my area equation to get A equals 85 minus W times W. So my area equation, my quadratic that I'm going to work with, is 85W minus W squared. The very same similar process that we did for the last problem, it is going to be here for this problem for part A. Now it is asking us for the length and the width that give the maximum area. Now in order to find this, it's basically asking us to find, this time, the x coordinate of this parabola. The reason being is because since W is on our x-axis and A is on our y-axis, the width that will produce the maximum area is still occurring at the vertex. So this time we want the x-coordinate of the vertex because that will give us the width that will produce the maximum area. So then to find the width, aka the x-coordinate of the vertex, we're going to use the formula negative b over 2a. So b is 85, so that's going to be negative 85 over 2 times 2A, which is a -1. And then that's going to give us the width that will produce the maximum area. So 85 divided by 2
42.5.
is 42.5. So the width that will produce the maximum area is 42.5 meters. To find the length that will produce the maximum area, we're just going to plug that in for W back here in this yellow circle. Again, I'm not looking for my area. I'm not concerned about my area. I'm concerned about the length. I'm concerned about the length of this rectangular area. So when I plug it back in, 85 minus 42.5, I'm going to get 42.5, correct?
Yes.
Okay. So then that is the length and the width. That'll give me my maximum area. Now for part B, we have a different situation. Farmer has 110 meters of fencing this time to fence off a rectangular area. However, one part of one side of the wall has a length of 15 meters. Okay? So this wall right here represents 15. So this part that I can only fence off would be just this part of this side. To represent just this part of this side, I would need to subtract 15 from whatever the width is. Okay? Because normally that entire whole side would be just the width, but since I have a wall that's 15 meters, I need to take away that 15 meters from that width on that side. So I'm going to basically need to go through the entire process over again. So then that way I can find the dimensions that will give me my maximum area. Perimeter, unfortunately, is not going to be 2W plus 2L. It's going to be 2L for the length and the length, 1W for this width, and then W minus 15 for this width. So 110 meters of fencing is going to be used for 2L plus 2W minus 15. I need to again continue to solve for one of my variables. And then that 62.5W is what I plug back in to my area equation of length times width. So area equals 62.5 minus W times W and this is the equation for my quadratic. Again, I'm looking for the dimensions that will give me my maximum area. So again, I am looking for the x coordinate of my vertex. So that's going to be negative b over 2a. So it's negative 62.5 divided by negative 2. $31.25. So then that represents the width that will produce my maximum area. And just like before, I plug it back in over here to find my length. So what's 62.5 minus 31.25? And that is how you use your different properties of quadratics to apply them into real-world situations.